Hello everyone. So today we will be seeing how we can solve the second order equation via using Runge-Kutta method. So basically we will be also known as RK-4 method. So that RK-4 method we will be using in our second order equation. So it's the mx double dot plus bx plus cx is equal to 0. So that second order equation we will be taking. So ABC are basically nothing but the constant. So that constants we will be eventually defining in our C++ program. So the first thing which we are going to do is first we have to convert it into a first order system. So basically x1 is equal to x position and x2 will nothing but the differentiation of the x1. If you differentiate the x, you get the x dot, which is basically the velocity, which is basically the rate of change of position with time. So similarly when you do it, so if you rearrange this thing, you will eventually get it in the right hand side. So this will be our function 2 and this will be our function 1. So that we will be also describing in here. So the RK4 equations which we already know, the general formula is basically this is the K1, which is the function f of x, and the other one is the slope. So at the end x1 next, which is basically nothing but the update of whatever the values we are getting from k1, k2, k3, k4, and x is nothing but the initial value, which is basically also known as the initial guess for what we have taken to solve this equation. So how we will be writing in our C++ program will be like this basically. So we will be creating for two function and function 1 and function 2. So function 2 is basically the velocity part calculation, the RHS part when you rearrange x double dot equation we have already seen, and the function 1 basically the x dot. So similarly this is how we will be writing in here. So k1, k2, k3 and k4 we will be writing like this. So at the end we will be doing the summation of these two guys. So then we will be implementation. Basically the gist of what we are doing is the function 1, function 2. Then we will use in the for loop for simulation for 100 second, 10 second as per to you, and that we will also be using how much we have to increment 0.1. So 1 to 2 it will be incrementing like 0.1, 0.2, 0.3 from 0 to 10, 0 to 100, something like this. So k1, k2, k4 it will be computed, and then x1, x2 it will be computed, and then it will be plotted the graph, the GNU. And the application main is it represents basically spring mass system. So another one is the oscillations you can see, basically the pendulum damp of oscillation that you can actually use it by. Another is the mechanical vibration. So this is how generally it is used. So let's get started. For output to plot in GNU. So this is what we are going to do, and then using namespace std we will be writing here. Okay, so now first what we will do is we will first define the constants. So when we are defining the constants, so the first constant will be a, so we will be using as double a is equal to 1.0. similarly b will be equal to 0.5 and c will be equal to 4.2. so this is what we will be doing. And also as we had discussed earlier that x dot, so basically it represents the position, so not position, sorry, velocity. So it will be dx1 upon dt, so that we will be representing it as x2. So when you differentiate the position you get the velocity. So similarly we will be writing the function here as declaring the function as double f1 double x1 comma double x2. So here we will be writing, and here we will be writing it as return x2. So this velocity it will be returning, and similarly you will be writing here as double f2 double f2 double x1 comma double x2, and inside we will be writing our main equation. So basically when you simplify for x double dot you will get the right hand value, right, when you are simplifying the x double dot, so that we will be writing in here. So what we will be writing it as return minus b upon half into x2. So this we have already discussed in our PPT, that this simplification, when we are rearranging the equation, it will be on the left hand side and the right hand side. So that right hand side we will be writing c upon a into x1. So that we have already written, so it's declared. So now let's write the main part into main, and again here we will be writing in here as see, I wrote it a bit wrong, so now it's clear, now it's correct. So now we will be writing here as double t is equal to 0.0 comma h is equal to 0.1. So h is basically the increment, so it will be incrementing by 0.1 and t is the starting part. Similarly, we will be writing for till how much time we have to run also, so that we will directly declaring in our for loop basically. So here we will be writing it as x1 is equal to 1.0 basically, and double x2 is equal to 0.0. So now we are already here. So this is basically the gaseous value, initial velocity, initial value we can also say, that is more formal, initial position. And now we will be writing in here as upstream file. So we will be writing here RK-4 data.dat. So in this dat format we will be saving our output. Basically the output will be our position and the velocity, that's it. And similarly we'll be writing in here as for loop, declare the for loop for int I is equal to 0, I is less than 100, I plus plus. So this is what we are going to do. And similarly we will be first save the output part. So this will be file t, and then we will have to get x1, and then again x2 we will have to write. So and L, it will just helps you to analyze. Similarly we will be writing it for the C output part. So C out is nothing but this, control C and control V, but we will be writing here some more. So what we will write as time. So this will be our time, this will be our POS position, and similarly this here we will be writing it as velocity. Okay, cool, good to go. Now for the next step is important part basically. So I will just write here RK-4 equation. So here we will be writing the main part, which is the Runge-Kutta method. So this is here where the computation will be happening. So what we have to write it as double K1, as we had already discussed in that our PPT, F1 into x1 comma x2 semicolon. Similarly control C, control V. So here we will be writing it as K1 2. Here will be F2. So this guy is basically the solving the two functions which we have defined here, F1 and F2. So we have to declare it for F1 and F2, the two, and then similarly we have to write the second equation. Basically we had seen the 4 part, and at the end we have to do the summation of it, which we get the final result. So we will be writing it as K21 is equal to h into f1 x1 plus k1 1 divided by 2, and then similarly x2 plus k2 1 divided by 2. So yeah, this is where to write, and then this thing again, do one thing, copy, Control C, don't write it 2 times. Now change this coefficient as 2. Here we will be writing it as 2. Here we will be writing it as 2. So again we have to write here double k31 is equal to h into f1 x1 plus k21 divided by 2 comma x2 plus k2 k22 divided by sorry, here we will be writing it as k21. Sorry, we did a mistake here. We were writing it k1 and 2. So here we were writing it as k21. No, sorry. Here we will be writing it as k11. Here we will be writing it as k12. So now again we will be writing the k21 and then divided by 2 semicolon, and then again copy paste, Control C, Control V. So we have written in here, and then again we have to change this guy up in here. We're writing here as f2. Here also we have to write f2. So similarly we will be solving it for the k4. So k4 is nothing but double k4 is equal k41 is equal to h into f1 x1 plus k3 1 comma x2 plus k3 2, and then again you have to put the semicolon. Okay, my bad. k3 2. I got it. So now it's good. Again we have to write here for f2. Similarly we'll be writing it for this f2. So now we have written all in here, and then the summation part. So basically you can say the update. So you write it here as update values. So reader written the update values. Again x1 is equal to x1, basically it will be equal to x1 is equal to x1 plus k1 plus k2 plus k3, k1 plus k2, I mean k11 plus k12. So I don't want to write in here as like that, so I will just write as k1 plus equal to, and then we will be writing as k1 1 plus 2 into k2, basically k1 2 plus 2 into k1 3 plus k1 4. Sorry, we will be writing it as k21. My bad. It just I am confusing it with the rows and columns of the matrix part, so that's why I'm just okay. So now we have written in here divided by 6, correct? So now we have to write in here as same x2 plus equal to, so instead of k1 we have to write it as k control v. So we will be writing in here as k12, k22, k32, k42. So we have written in here, so this is for the position update values and this is for the velocity, and same will be t plus is equal to h. So this is what we will be doing, and as we know h we have already given it as 0.1, so it will be keep on updating till we reach 100. So that is the main idea behind it, and then we will be writing in here as file.close. And then return 0. So now we have to since plot in GNU. So what I will be doing, first we will run this guy. Let's just check in here g++ rd12.cpp. Okay, we forgot to save. Control S, g++ rd12.cpp, a tab. Okay, so we have got these values up. So let's now we have to plot this guy up. So I will just clear this again, clear. So one of the main things you will notice that it has got this value. So here you can see all those values. So no need to keep on cluttering your terminal. Keep it clean, it looks much better. I mean, I like it when it is a bit clean because it helps me to just see what the thing is there. If I want to see the values, I will directly go in here. Okay, so now we will write the commands basically, which will help us to visualize the plot. So let's write in here as cd. Basically here I have to write the place where I have saved those files. So my file is on here. As you can see, I have my file in here. So what I will do is Control C, and I will write here Control V. So here we will do the slash thing, reverse the slash. So we have changed this thing up. So what you can do is basically you can also check it whether that this guy is able to read or not for the GNU plot in here. So first I will just write in here as GNU plot for POS versus time. Okay, so what we will be writing in here as set title position versus time, and then set X label time, and then set Y label as position X. So now we have written all in here, and then set grid. plot RK-4 data.dat using 1:2 with lines LW2 TIT title position. So this position nothing but our line which we will be plotting. So we can just check this thing out. This command is running on. So what we will do is when this command is running good and the plot is seen, we'll change it with the ratio. So open this GNU plot. So first I will copy this command. Let's see, Control C, and I will just paste in here. So this is running. Okay, so now you paste this, Control C, and then you paste up in here, and then so yeah, perfectly fine, the graph is coming up. So similarly we will be doing this as, so you can see the positions, right, how the equation is behaving. It can help you to analyze. And now similarly what we will do is Control C up in here, and then Control V. So this will be our velocity versus time. So this will change up it as velocity. This will just write in here as VT velocity, and this is the main thing basically, 1:3. Okay, Control S. So now you will just paste this thing, Control C, again go to a GNU plot, enter. So this is your velocity versus time. So this is how the velocity is behaving. So this is how you can actually solve via using RK-4 method. And in RK-4 method you don't have to very less increment. You can actually have a 0.1 increment also, whereas in Euler you will have to keep it as like 3 decimal far away, 10⁻³ something like that. That's not necessary in RK-4. It is much more better and accurate. So this is how you can use to solve your second order equation using the RK-4 method in C++.
Like, share, and subscribe. And have the power